Hello, everyone.
Hey, good morning, or I guess technically afternoon.
For a few more people to join and get started. Okay, there's some people here now. Okay, welcome to Stormwater Management Design and Criteria. Here's our agenda for today. We're going to talk about this agenda. We're going to go briefly go over Stormwater Management Manual. And then we're going to talk about choosing ESG facility. And then we're going to talk about how can we provide ESG and IR. And then we're going to go over the EMP design spreadsheet, delineation, and then grading. If we have time, we can do them grading and following the environmental design guidelines. And so first thing first is we are going to piggyback on what have we been doing for the past session with I-81. So I'm going to be using I-81 for a one-to-one management facility and mailing this for a different stormwater management facility. So first, let's go over what the resources for stormwater management manual and how to read it. So a lot of projects that we have are basically for SSA and county jobs. Typically for SSA, we usually focus a lot on soccer farm facility. Uh, and you can find the manual in this library under BMDE, Shoreline Management Guidelines 2000. The to this bottom, volume one, volume two. It's reading volume one. Now, for those of you that want researches, I highly suggest that you take time and read over this manual. It just has a lot of information and calculation that help you understand the process of what we do. but for the purpose of today's training, I am going to focus on chapter 5, okay? Which is environmental site design. Okay. So basically the goal of the stormwater management to, provide stormwater management strategy to treat the runoff, mitigate adverse water quality or quantity. So what we mean by that is, okay, when if you imagine there's a forest, right, and 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 water is raining in the forest, and you see that when water drains down to the forest, there's so much that's flowing down that water, right? There's wood, there's grass, there's high grass, and they're flowing down that water. So when we start to do new development around that, we put in roadways, we put in houses, parking lots. We are changing the land of that area, right? Because when you go from grass to impervious, your infiltration rate is so much different. Now, when you have like roadway, there's no real infiltration rate. So, so what happens when you put a road in the middle of a forest and it rains? What's the difference between that? The difference between that is water uh, is not being slowed down anymore because there's no grass, there's no infiltration, there's now the road. So because there's road and water is going inside into the road, water is going faster and faster and faster. And because the water is going faster and faster and faster, it's gonna impact the area around it. It's gonna flood, maybe because the water is going so fast, it's not getting a chance to infiltrate the ground. And so we have to provide design to possibly divert that water and to treat the runoff of that water associated with new development. So when you talk about quality or quantity, quality talks about the water itself, while quantity talks about the flow of water. And so there are many different types of facilities that we use to treat water quality and quantity. Let's see, there's so many. Mm, it's my page. So sometimes the purpose for amendment design is to try to get your site condition back to what it was previously in terms of your code number. So there is many different others. The alternative surface green roof, permeable pavement, reinforced turf. And this manual will give you all the basic design criteria for each facility design, as well as like guidelines, maintenance criteria, and things like that. Yeah, not connecting that runoff. But for the purpose of today's training, I'm going to focus on what we use a lot for HSA, which is spiral whales, west whales, glass whales, and microbial retentions, which was also called part of microscale practices, which yeah, microbial retention and 12 we use a lot of. Now, sometimes, depending on the circumstances, we will use submerged gravel wetlands. And the circumstances which I will explain in the next hour or so depend on the land itself. Again, I strongly suggest you go over this manual and use this as a resource and guideline to help you design things. Alright, so let's focus on microbiologists and biofuels, okay? Well, alright, so we have grass wheel, Westfield, and Boswell, okay? Now, these three always have different criteria, and one of the biggest criteria is what type of soil that we're doing the work in. Is it A soil, B soil, C soil, or D soil? The difference between that is we determine whether it's a well drainage soil or poor drainage soil. So that's the first step is determining what type of soil it is. So let's open up our training project. Now we're going to be focusing on one POI. Let's go to our process and calculation and soil amendment and the soil amendment condense. What we did before. Uh, so, so you see here this example project. When we first started, we just did one POI. Okay? And it turns out there were lots of different POIs in drainage areas. Anyhow. And so when we first started one POI, we decided we have to treat showing this number so and so. Okay? And then what we did was we inputted it into our summary sheet. Okay? Our summary sheet. And then as a result, it said, no, we have to provide a certain 14, 30, 35 cubic feet. So here are these high rules saying for each POI we have to treat the ESDV in each POI regardless, which is why each POI here. So let's say I'm going to delete. So right now in POI 1, which is what we're going to be doing, we have to treat 1,435 cubic feet. So, but how we designed that? Okay, so we have different spreadsheets to use for design. So we have which you can locate in the live, and I think it's Project Engineering Resources, Stormwater Management Spreadsheet, and Stormwater Management Calculation. No, that's not it. ESD facility. We have bioswale, grasswell, and muck bio retention, and wet well, which is what we use a lot of. Now, now, how do we choose which ESD to use? Again, it's all about the site condition, and also it's about your limit of work. Cause when you're doing work in HSA and PRD, we have to stay within the right of way because that's owned by the state. So if you go outside of the right of way, the state has to properly pay a private owner to obtain that right of way in order for us to use it, which they don't really want to do. So let's go to our drawing. Now let's just go to water quality. Alright, so we're going to be focusing on POI 1. Okay. So because POI 1 here, we have to determine what's the best location you put in someone in this facility. And so, but we have to do it within the property right away. And just right away. And so, in order to determine that, we have to look at and say, okay, this right away here, how much space do we have in here? So we want to measure it, measure how much the space on the proposed. We have like about 80 feet. 80 feet. So, okay, that's a lot of space to do. So, so we want to be say, okay, maybe we can put a swell here. And the reason why I'm saying it's a swell, put a swell here, because in the existing condition, there's already a swell here in the existing condition. There's already a swell in the existing condition that's flowing down. So okay, look at that. Okay, there's already an existing swell there. So let's utilize that existing swell instead of creating a whole new swell, which just change the slopes and everything. And so now, once you get you're located, okay, maybe you want to put a facility here. You want to be able to determine the drainage area to the facility because not all stormwater management facility has the same drainage area. There are limits to each facility on top of the drainage area. And so I want to put maybe I want you to buy as well here, grab well grass well, west well. Let's see, let's go to Rain Garden Trail. Now you see here it says Glasswell works best in A, B, C types. Westwell are suited for seashore or deeshore. Glasswell can be installed in all shore types, but it has under drain. Uh, so we have these criteria. Also, some of the criteria here. Less than 4%, maximum plus velocity, free boy, shear, size up, etc., etc. Now, typically, as well, the maximum drainage area is 1 acre for as well. Now, if you see, we go to our spreadsheet, and look at the Boswell spreadsheet, which I got from the engineering resources. Okay, which is in the P drive and engineering resources. And so I made spreadsheet ETV in Boswell. So Boswell should see as a maximum. This is a standard, our standard on total amendment spreadsheet calculation. Like you see, a Boswell has a maximum drainage area of 1 acre. And so now that we know it's a maximum drainage area of 1 acre, let's go back to the drawing and see, okay, maximum drainage area 1 acre. What type can I use? Wet well, grass or box well? We have to look at the soil in here. The soil here is okay. This is the soil. Yeah, that's poorly drained soil. And so we know from the manual that grass well can't be used because we have A, B, and C. We do wet well, or C already, or we can do bars well. for this one, so I want to say, okay, let's do a bioswale. So I would shoot, so I'm gonna go back to the drawing. Now for ESG facility for design, we typically want to do it in the MDE drawings. So go to validate individuals. M the MDE is site environmental site design for the model, environmental site design. Shot. Now I should do this. Now I can just reference one of my maybe my composite drainage, my water quality. Maybe this one. Right, nothing. Mm-hmm. All right, so let's see. Right now we're just focusing on this POI one here. Let's see, and then let's see, this is turning around. All right, so y'all want to put like a box right here. So let's see. We can do a 2 foot bottom, a maximum 2 to 8 foot bottom. And so because based on the spreadsheet. So let's just do. So you got the draw here, drawing your diagram, EST practices, micro scale EST, yeah, Westwell, Boswell, Boswell. And then you can probably do like a surface area, and then boundary. And so what I really like to do is sometimes I like to follow like the flow of the Boswell here. So I like to possibly draw a line here, maybe like up here, like that. And then I will just do offset exactly the width. Let's just maybe do like a 4 foot width of all offset this copy parallel by 2 on each side to make it a 4 foot bottom. And then what I'll do is I'll make sure it's even here, and then I'll add a vertex, and I'll vertex here, and then I'll create like a complex shape, and do a automatic. It automatically select your shapes when they're connected, and then I'll do like a fill line opaque. My fill, and to help me see it better, I can make it transparent a little bit. Okay, so now we have that. So okay, now we have a 4 foot bottom, which we can put in our spreadsheet here. We have a 4 foot bottom, and what's the length? You just measure the length, uh, 9 in the measure distance, and do a long element. And go, okay, that's 251. Okay, that's so we have our line. We have the side slopes, a 4 to 1. But now we have to go, okay, how much drainage area you get into it? And I remember the maximum drainage area has to be 1 acre for about 12. So we have to measure our drainage area based on the contours here. Now roadway will usually have proposed contours for you based on the roadway. And most of the time, it's usually what the existing is. If all they're doing adding like a shoulder here. But for now, we're going to use this existing contour. So in order to do this, you have to go to impervious pieces, Mexico, Boswell, and the contributing area, which is the drainage area and boundary. So usually, again, for just like delineation, you know, I'm assuming that the trail will come down to this fire wall here, and this will come down to the fire wall. You're gonna take it from the beginning of the fire wall here, follow it perpendicular to the contour. As you can see, there's like a high point here. And there's a road. There's a road here. Then I was just follow the line contour until we get to like this end of the square here. It has to be perpendicular I like to just go here and then just close it out like that. And then adjust accordingly. And now, but also there's also some flow coming down here. I can see the contour coming down. So you want to like just maybe the fiber coming down here, some of the flow coming in here, and then there's like a split here. And maybe it'll probably just come like like this around. Okay. So that's the change here to this balance well here. So what's the area? 9, like the area in square feet, 32980. And this all in detail. So 3,280. So, so we're just gonna put that in now. 3,290. That's 0.76 acres. And the maximum acres is one. They were good to go on that. But then you have the impervious area. And you should figure out how much impervious area you get into it. So for this one, you can just well, let me make sure make sure all this is correct. 34802. Now you want to see how much impervious area is getting to the fire well. So you want to decide you want to get as much impervious area as you can to drain to the fire well, because in the requirement that we have for POI 1, we have to treat an impervious area of 0.16 acres. And so let's figure out how much impervious area can we get with it. So the way you do that is you can just represent your MLU P file, which is the proposed land use file. And then you know nothing. And let's just send it to the back. Update sequence. Let's send it to the back. Let's just turn off. Mm. And then, so that's our proposed land use file. And we'll figure out how much impervious you get into there. Into the area of a flood. Is that 11,547 square feet. Go to buy, so I'll put in 11,540. So we're getting 426 acres impervious area being about for us. And now we have a target PE of 1.6, which is your runoff per se. Now, Now, now for facility, how you know we're treating enough of it? The general rule is you always want to treat at least 1 inch of rainfall. If you're treating more than 1 inch of rainfall, then you're treating the all the impervious area. If it's less than 1 inch of rainfall, you're not treating all the impervious area. And it's based on your calculation in the stormwater manual. Okay, now we have the area. Okay, we have the length, we have the bottom width, we have the size slope. I wanna determine our slope here. Right now, I have 0.0005 feet per second. So what I want to do is I want to look at, okay, what's our existing slope here? So currently I see what is inverse here, this elevation 633. And then this elevation here is 632. So currently I'll just measure the length between the points here and see 252. So it's 1 divided by, that's 0.0039, which is less than 0.5%. But we don't want to do that. The minimum for proposed we want is usually 0.5% or more. But because this is so, it's not, it's such a low slope, we'll keep that a minimum of 0.005, which is 0.5% slope. What we'll do here. And then, you have the check dams here. Now, a check dam is usually only for a biosphere itself. A check dam helps you store more water inside the swell. And let me show you a detail what it looks like. So you can go to your stormwater management resources, and I have it bookmarked here. Stormwater management design guidance. Okay? And that's all the guidance for a shift. But you can also find it in the library, believe. I believe that's where I put it. Oh, design, design guidance here. Now we want to look at, okay, Bioswell A, B short or CD short. So we're in D short. So we want to look at this facility here. Look at the basic typical section of a Bioswell. So this is typical section of the Bioswell. As you see here, this is shut down, shut down. And the reason we have shut them here because from here to here, you can provide storage or ESTV treatment within the shutdown. So the higher the shutdown, the more storage or ESTV that you can treat. But now here I can see we have under drains here as well. The reason we have under drain is because this is in diesel, it's poorly drained soil, so it's a very low infiltration rate. So you put under drain in here in order to drain this water so it doesn't like flood up and then outfall. But shut this um detail, shut this for the middle I just off with everything. Okay. Um yeah, let's go back to our spreadsheet. Yeah. So Shazam High 1, which is pretty standard, and Shazam Design Station 50. So the station is generally the space of 50 feet minimum from center of Shazam to center of Shazam. Front slope shift to one, to one. What this means is it's talking about the slope of your Shazam, which is just one slope and just one slope. And now is a profile. And the next, it won't be in this session, but the next session, I'm going to show you how to draw profile according to the typical session. So you can see how to draw it. But right now, we're focusing on the design. Okay, so we have all the information here. We have the length and everything. And then it'll give you the storage, total surface area provided. And now you want to figure, okay, your issue, the table here will is based on a formula of how much PE you'll be runoff you've been treated. So it actually provides some kind of iteration here. But the goal is to make sure this percent actual is the same as the percent actual, the same as percent required. So it's between 2.4 and 2.5. So that's still 2.45, like 52, 52. So the ESDV is provided is based on the P 2,476. And your impervious area credit is 126. Okay. So now remember how I said if it's because you're providing a PE greater than 1 inch, 100% of the impervious area can get treated. Now, but what happens if it's under one? What if this was 0.8? You're only considering a partial of it, which is 1.1. Now, let's go back to 2.51. Now, this ESTV is based on the swell length and width and the slope. So right now we have 2.45. What happens if we change this swell length to like 100 and then change the bottom with the 2? Ah, as you see, as you see here, the media surface area has to be redesigned. The reason why is that the area has to be greater than 2% of the contributing area. which is the drainage area. Because drainage area is so big, so you have to redesign, okay, let's say 4 feet, 346 square feet, which is greater than 2% of 3,400, 34,802. What is that? 34,802 times 0.02. 990, this 190, greater than 2%. Right now it's at one. Right now it's at 1%. So we know this has to be at least 700. So let's, if I increase it to 8 feet bottom, okay, now it's 2% here. So what we had it before at 251 and 4 feet wide, which okay. But not now. But let's say okay, we have 100 foot and 8 feet width. Let's look. Let's go back to our PE treated. Now the PE is less, so you have to reiterate 1.55. Now the EATB is less, and to go with the so 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 let's look at our look at this. Let's look at our environmental summary sheet and see what we need to treat. Here it says we need to treat 1,435 cubic feet. So here we have 1,566. So it doesn't necessarily have to be uh, 251 feet by 4 feet wide. You can adjust it, but you have to be careful because when you adjust the length and the width, you also have to adjust the drainage area. Because when you first start out, okay, 251, if you want to go 100 feet, you go see where 100 feet is. You usually start from the top, where 100 feet is. 100 feet, let's say 100 feet. That's only like up to here. That's 100 feet. That's all up here. So that's going to be where the end of my trail is. But what happened to the drainage area? It'll, it'll be drastically smaller. And because your drainage area is smaller and the end of the trail is here, the impervious area treated becomes smaller as well. It will probably only be like up to here. And this our drainage area, and your impervious area will only be up to here and then here. And then we'll be like, okay, if we did that, what would our impervious area be? You measure it. 4,934. That's only 0.11 acres. And so we need to compare that to our spreadsheet. If I remember correctly, we need 0.15 impervious area be treated. And so again, it's all about adjusting it. You can make it, okay, let's say let's make it 200 feet. It'll probably be enough. If you make it 200 feet, yeah, you like it'll probably be like right here. 9,118. 0.21 acres. And so it's really all about trial and error, seeing what's the best way to design your body well. To get the most that as you possibly can. But for now, we're just gonna stay with what we have so far. And and really, it's all about adjusting and doing your engineering judgment of how to design this well. But now we're going to stay with our shooting and credited. We are going to put this number ESTV credit into our summary. It, PY1, we said okay, we showed about it well. It can be by well. It can be any number that you designate. And it should appear by project. We go here 2.45. 2.45. Yes, he provided was like 2,472. And then you're providing the POI on, and it's a POI requirement. You say yes. So the goal is to have all of this be yes, so that if your POI requirement is met, your entire project ESTV requirement is met, as well as your impervious area treated. Oh, it's a lot. There's a lot of information to take in, I know. But once you practice, you get the hang of it, you should be good. So that's a bioswale example. So you have your drainage area, it's your bioswale layout. Let's start with that. Okay, so we go to our agenda. We went on spreadsheet, sizing, delineation, PTV provided, IR provided, so okay. So that's one bioswale. Now, before I get into the grading part of it, I want to go over a different type of facility, which is a microbial retention facility. And for that, we're going to go to a different project. So here we have MW. I'm going to show you this technically is the same process for delineation of a microbiota and a background. So you have the water quality. So let's go to the hydraulic and look at the calculator that we have. Whoop, I can open to it. Just see um I don't have open, do I? Alright. So here, so this project you only have one POI, and you have IR of 0.11, and you have an ENTV that needs to be provided 876. So we go back here, okay. Let's just see MES, MHD, a second, the one work be done here. Now this all just one POI. And so let's let's figure out okay, right away. Uh, which we should have already in the MIE. Okay, so this orange is SSA right away. As you see, we have plenty of right away space here, but we have to look at our contours. Let's look at our existing contours. MGI from the survey. Okay, so I see. Okay, so I see we have an existing swell here. Uh, so I'm gonna we could put it maybe put like a swell here, right? Maybe okay, I see a swell here, right? But we have to be careful because we decided the maximum drainage area to a swell has to be what 1 acre, correct? So if we will put a swell here. What we're saying, okay, how much area we begin to it? So from the existing, I'm assuming, okay, all this will go into this sponge area. But also, you have to be careful. Let's look at the pipes here. Now you have the pipes here. Cover coming here and then come into the dish. So we can safely assume, okay, you have area coming to the cover here. You have area coming to the cover here. You have area coming to the cover here, all going to here. And it's pretty fair to assume, okay, this is more than 1 acre. So it's not feasible or it doesn't make sense to put a bioswale here. So so if we can't put a bioswale here, what's the next step that we can do is like I said, we typically do a lot of um wet swale, grass swale, bioswale and medical bioretention. So we wanna look in our area and see where we can utilize them a space for a facility. Now we could maybe we could have put one here, but I don't think that would have been feasible. Now let's go to our macrobiology spreadsheet. Now the maximum drain area to a macrobiology has to be 0.5 acres in the maximum drain area. Now I'm thinking, okay, if I put one here, you know, it's a lot of area going to it, I assume, because I'm looking at the culverts here. These are Egyptian 43 by 27, 20 culverts, which are pretty big culverts. So I'm assuming it has to be way more than half an acre. But also, you can also reference in the drainage area, your MDE, and figure out, okay, wow, like this culvert here, it's clearing all the entire area. That's way more than half an acre. And it'll go to all over here. And so it didn't make sense to possibly put one here. Now, maybe what I believe put a small one here somewhere. Okay, here. Okay, it's easy. You have to look at it like in terms of easy to grade. Because you see, you have a lot of space here. And here, you have a lot of space. I assume that it'll probably be more than half an acre here. Now, probably the best place to put would be like somewhere like here. Okay, so, so let's go back to our shoreline. So we need to treat 0.11 acres and 876 acres. Now, first, we gotta figure out what soil it's in. So what soil it's in. So I'm gonna create my MDE file. And I'm gonna represent all my attachments that I need. MJE. And then I assume. Okay, so let me figure out what our chores is. Let's see, do we have a chores map in there already? Yes, we do. Chores. Let's see there, Phil. And let's send the two back. Then let's see sequence. Let's send the soul to the back. Okay, I showed you. So wait, this is all in seashore, okay? So that means it's poorly joined shores. We know that it's poorly joined shores. And so let's go back to our guidance, our Stormwater Management guidance, design guidance. So we have A, B, so microbiota, C, D shores. Now because it's poorly joined, we need an underjoined here. And this is what the turbo section looks like for microbiota. We need under drain and then I pipe alpha here because it's usual. Then I have an MDE and then so I wanna just create a footprint maybe. Microbiota surface area boundary. Let's just say okay to we'll place a boundary like this. And then we'll just do like a general drain area. Okay, let's go in here. So what's the square footage of this area? 796. 796. Still low. The slope is 0 because the bottom of the microbiota is flat. Right? Then okay, let's see. I'm assuming it's gonna be a size number for the one. Okay, so for now, I'm going to say, okay, yeah, this impervious area again today. Yeah, this new impervious area again today. It should be asphalt. So we want to figure out, okay, how much impervious area again to this micro validation? But I lied. Our highway says that they have a curb and gutter detail here. So what does that mean for us exactly? That when you see a curb and gutter, how how is the water gonna get here? So when highway put curb and gutter, and we start one facility here, what do we do? How do we fix that to make sure I'm having impervious area drained to here? So what you do is to okay tell highway okay we want to put maybe a curb cut here in order for water to get here. So it'll probably be like a curb cut here. So that means if we imagine okay we're gonna put a curb cut here, then we can delineate our drainage area, contributing area boundary. We just say okay, I'm assuming it'll go like this here. Powdered and powdered kind. No, actually, we'll go back. Because water will hit the curb, right? And the curb is tossed all the way down here. And then the curb also here. The water come down here. So we probably have to start here. And then just figure out. And then you're going to put a curb cut maybe here somewhere. And so we have to say, okay, there's probably going to be a curb cut here somewhere. So we go where the curb cut is. And I didn't wanna probably be like on the curb. And anything that hits the curb will go all the way down to our maybe our proposed curb cut. Our proposed curb cut here. No, we have a proposed curb cut all the way down. And so I'm going uh I'm going to create a compass shape automatic. Let's see. And figure out what the drainage area. Yeah. Where 9,142. It's in diesel, right? 9,142. Reflection, half an acre, perfect. Now we're gonna figure out a contributing area. Let's turn on, let's put on MLU P. And then just take a flat area. No, not that one. 7,239. 7,239. 0.17 acres. So, in 0.17 acres, so let's go, contributing rainfall of 2 inches. It's greater than 1 inch. So we're good to go on that. You have our surface area. We have our side slope 41. We have the ponding depth, which is your ESDV depth of from the bottom of the micro retention to the top of ESDV that you want. So typically we want to be 1 foot. Which is here. It's ESDV here. You typically want it to be 1 foot. It can be lower, but you're not gonna get as much volume treated. So we typically want to start this off at 1 foot. And then here is where you okay. We know that it's 4-to-1 side slopes, right? So how do we get this square footage? Basically, what you do is you just take AutoCAD, so we know it's gonna be 4-to-1 side slope. So every foot of elevation is going to go horizontally 4 feet. So it's going to be 3. Going to copy, move parallel, and then 4 foot. But for half a foot, it's going to be 2 feet. So you're going to half foot, 3.9, and then 2 feet. So what's it? 1,043, 1043, and then this one is 1316. Alright, so let's figure this out now. Okay, so we have a piece reader. Okay, so divided by 1,449. So we are maximizing our PE treated because 2.6 is the maximum that you can go. So we're 2.0. So technically we're over managing it quite a bit, which is fine. So we have a contributing area of 0.17 and an EACV credit of 1511. And again, put this number in our summary. in our summary table. So maybe in our summary table here, macrovalidation 2.6. Then we have 1511. That means you're providing P 2.6 and site environmental protection design cubic footage of 1511 with and then the PLI requirements met and then this yes. Okay. And that's basically how you do like site design is that trial and error of looking at your site area and seeing based on your requirement and criteria for everything, how to adjust and design for it. So number one, look at what shore types it is. Okay. And number two, the right of way. Is there limited right of way or there a lot of right of way? And number three is how much impervious area can I get to my facility if I place it there or if I place it here? And how much drainage area will get to that facility if I place it here? You know, I have a maximum 0.5 acres for microbial junction, maximum 1 acre for the well. Okay. So that's the basic of like how you do design for microbiology and biology. Okay. Well, let's look at our agenda here. Now we're gonna look down. Now I'm gonna go over the grading for microbiology and biology. Again, it's all about looking at your existing area. So let's go over the grading for a microbiologist first and see. So let's look at our existing grade here. Okay, so this existing grading here is actually okay. This is 725 the Egyptian. Okay. Now I know this is 700 elevation 725. So let's just say, okay, if I what if I make my bottom of it 725? I have one for a bonding, 726. So we know so if I make it just 725 here, a full one flow, this has to be 726. And this is 726 here. And this is 727 here. And this is 728. And that's okay, that makes sense. But you have to realize, okay, if this average 726, I have 724 here and 725 here. Just figure out, okay, how am I going to tie into 724 here? Now, this is where you would create a berm. So you would create like a berm here. So you would go 4 to 1 side slope. And then you would have like a berm here. Like a flat area. And then it will come down and tie into this existing ground. Uh, so let's work on grading. Now, for me, I like to work on my grading and the MPE file because it's a 2D file and it's so much easier to work with than a 3D. And then I like to work on that first, and then copy it over to a 3D file. So, let's turn it. But we want to make sure, okay, let's turn on our MHD. Let's turn on our MSD. And all of the existing. Just so we know, okay, we're not impacting anything. We might be impacting this thing here. So, now what if we move this over a little bit? So we're not like impacting it. Well, so this is gonna be the bottom of my microbiology. But I want it now. I want to look nice a little bit. So I want to like make it nice and rounded. There are several ways that you can do this. You can do it by circular fillet or by point. So what you can do is, no, you can do the tie. You can do a smart line, beach line by point. That's one way to do it. You could click. Um, just to make it smooth as possible. To create curves, beach line by point. You just do click on the curve here. And then you have like a nice little circle area. That's the quicker way you do it. Or you can do or you can do mm, construct circular fillet. If you construct the circular fillet by 7, 9, you can choose the radius that you want. Let's say 4. Shrunk to none, but I want to do both. And then you cook one side. Uh, or maybe you want a larger radius for this one here. You can do like 10 maybe. Do 10. No, just It's just a basic overall. And maybe I want to do like 20. No, either way was. Then, but you have to make sure, okay, you want to combine this to a shape. Okay, now this is 725, and you want it to be like a 4-to-1 slope. So you can just do offset by 4. Okay, now that's 726, right? And that's your HDV upon elevation. This 726. And to help you distinguish it, you can just change the you'll say that's the grading. So 725, 726. And then this is like 727 here. But where's 727? 727 is all the way out here. I'm like, if my 727 all the way out here, I'm gonna have to build it up all the way, you know. And now I'm realizing, this might not, this 725 might not be the best way to do it. So I'm like, okay, let me lower it a little bit so that I can tie it to 725. So let's say I want to make my bottom 723. Let's see. And I'm just 723, 724, and then just 725 here. I can tie into the 724. But also, I feel like I need a berm here so I can have water flowing down. Okay? The other 723, 724. So I need a berm. So that's at the same elevation. So I would make the 724, then I would make this 724. So how to make a berm. So at 724, so I will. So that means that I have 724 here, and my berm here is 724. That means my next contour has to be at 725. So now because I have a berm here, I don't have to go all the way here. Because this is going to be 725. No, no, no. My bad. I'm sorry. Okay. 724. Then what you're going to do, you want to create a berm on the downstream side of it, not the upstream side. And so what you can do is you can cut this here, right? And you can cut it here, and then you're going to do 4-1 slope, and then you can cut this so that I tie into 725 here. And then you have the 724. What you do is you can just loop it around and create a bump. So you can just probably go, because you have to look at the drainage area the way, because this is coming down 725. It'll come down to 724, but also come down to here. So you can probably go up on like that, and then tie it to like this portion here. Okay, so now, what way does it mean? This means that, okay, when you draw your updated drainage area for this micro valve retention, you have to go to across the sperm here, and then I'll come down, and then you figure out, okay, to where we had this 12 before, and then you have this well here, across to this, and then remember there's gonna be a curve cut somewhere like right here, and come down, and then I settle. No, like that, hold on, so that'll be your drainage area. Then you just clean it up by doing circular fillet and can. This might have to go smaller. It has to go smaller as well. Circular fillet. Maybe may have to like extend this line. Like that. It's just 7-9. Oh yeah, you have your so that's why you have your bioretention, microbioretention layout footprint. And then you wanna create a complex chain automatic like that. And then what you can do is when you have the grading file, you can just uh, copy the grading over to the MGRP file and then make it to a 3D file. Uh, yeah. But I think tomorrow we'll be doing inroads about how to create DTM and profile for Stormwater Management Facility. And so the next step tomorrow, I will show you how to copy this over into the grading file and assign elevation in the 3D file to your contours graded, and then make a DTM for it so that you can see in the profile. And that'll be for tomorrow. And tomorrow we don't have time for the glass wheel house we're grading. So when we get into it tomorrow, I am going to go straight into the BIOS regulating and then in mode tutorial. Um yeah, so I believe that'll be it for this section here. This will be recorded and posted into the folders here. And again, if you have any questions, let me know in terms of design. I know I went a little bit fast, but but take the time to go over this and study the manual and the spreadsheets and stuff. And that's it. Have a good day and
Yeah,
yeah.
thank you, David. Dave, for very good presentation. So thank you very much. Hopefully everybody learned a lot from this. Our session is tomorrow also, right, Dave?
Yep.
Okay. Thank you.
Mm,
Have a good day. Bye.
Thank you, David.
mm.